So let's talk about rate of change. So you'll notice on the left-hand side of the screen, we have a linear function. And then on the right-hand side, we have an exponential function. So what makes a function linear and what makes a function exponential? So in the prep, you explore looking at the rate of change for linear functions and the average rate of change for exponential functions. So the rate of change for a linear function is the slope. So if we calculate the slope between these 2 points, we're looking at the rise, so how far do we go up, right, over the run, how far do we go over. So we can actually calculate our slope. So our rate of change is going to be the difference in our y values over the difference in our x values. So our line has a slope of 3 or a rate of change of 3. And here, if I calculate the rate of change between another set of points, for instance, these 2 points. So we're going to do 8 minus -1 divided by 2 minus -1. We're going to get 9 over 3. We'll notice that we get a slope of 3. So between any 2 points on a line, we're going to get the same slope. So we get the same rate of change. However, if we look at our linear function, if we look at our exponential function, this is not the case. So let's calculate the slope here. Right? And we know if we draw a straight line here, so I'm going to get out my line tool. So I calculate the slope between these 2 points. Let me change that. I'm going to undo that. And I'm going to make this blue so that we can see it. The slope between these 2 points here. Right? We can see that's not a good approximation of the curve. So let's calculate our slope. Or here, this is going to be what we call the average rate of change. So we have 4 minus 1 over 2 minus 0. So we have 3 over 2. Now let's go in closer here. Let's look at a rate of change between these 2 points, or our average rate of change here. So 2 minus 1 over 1 minus 0, we get 1 over 1, or 1. So here we notice we don't have the same average rate of change. And if we pick points that are even closer, we're going to get a difference. So the closer we pick 2 points, the more accurate we're going to get, or the closer approximation we're going to get to that curve, right? But there's no way to actually calculate that, and that's why we call that average rate of change. So what are these actual functions? Let's write these down. So this, we could calculate the equation, which is what you did in the prep work, by first calculating the slope and then using point slope. So we would use y minus y1 equals m times x minus x1. And we could pick any point on the line to do that. So let's say, for instance, this point. So y minus our y coordinate equals m times x minus our x coordinate, and solve that equation for y. And that'll give us, so we're going to distribute here, our slope-intercept form, which is our commonly used form. So we're going to add 8, so the opposite operation there. A more common use form. So this equation of this line here is y equals 3x plus 2 is, and this is the form you'll see a lot of your equations in the lab. And then here, our equation, which we cannot calculate this by hand, or is beyond the scope of this course, is y equals 2 to the x. So our exponent is the variable, and that's why we don't have a constant rate of change. So that's the main difference here in our functions, is linear functions have a constant rate of change, where exponentials do not have a constant rate of change. So if we wanted to extrapolate and say, okay, well, what is y when x is 5, then I'm going to plug that in. So y equals 2 to the 5th. I can come to my calculator and do 2, and we're going to use our caret key here. It looks like a little rooftop. To the 5th and enter, and that is going to be 32. And we're extrapolating since our given data was between -2 and 2. So we're going beyond the x value. So a little bit kind of the prep there. So now let's look at the lab. And I put up Excel by accident. Apologize for that. Let's look at pen open here. So you've created your graph, and that should be similar to what you've done in the previous labs. So now what we want to do is use year 1, so aligned inputs. You should have read through that. And we want to find the equation of line by hand using the first and last points that best approximates the data for Tanzania. So what I'm going to do is come up here. I'm going to come in here and a little screen capture here and come back to my lab, and I am going to capture my data here that I need. So we want to come up with the equation of the line here. Right? So we want to come up with the equation of the line by hand using the first and last points. Okay. So we're going to first use the line inputs, and we wanted to use 2004 as year 1. Right? So 2004 is year 1. So those are going to be our x values, right? Since it's the independent variable rate, time doesn't depend on anything. So I am going to, these are x values. So this is 1, right? So we go up 1, so this is going to make this 2, 3, 4, 5. These are increasing by 1. And these are going to be our y values. Right? These are our y values. Right, and we want to use the, what did it say, first and last points to create the equation of the line. Okay, so we're going to go in here and use that as a data point, and this is a data point. So the first thing we need to do is create or find the slope. Okay, so I'm going to do my y corresponding x on the bottom minus the other y value, and then x minus x. So we calculate this here. Right, I'm going to do 60.5 minus 54.4. We're going to get 6.1, and if I divide that by 5, we're going to get 1.22. So what this is, right? So remember, this is our change in y over change in x. So if we write this out as a fraction, this is what we have. So if we interpret this, this is going to be, right, for, ooh, that is some big font here, so let's change that. So for each year passes by, right, that's our x values, the life expectancy at birth in Tanzania increases, since our slope is positive, by 1.22 years. So that's going to be our slope. And so now we just need to finish up and find the equation of the line. So what we're going to do here is go in and plug into point slope form. So we're going to go in and calculate this. So we're going to just pick a point, so we can use that first point here with 1. So plug in our y value and our slope that we just found and our x value. And we're going to distribute there. Right. So we're going to get x and then 1.22, and then we need to add our 54.4 over. So I'm going to do negative 1.22 plus 54.4, and we're going to get 53.18, and let's double check that. Right, so there's that equation that we wanted. Right, so we also can go in and interpret our slope, right? So remember our y-intercept is 0, comma, right, the x-coordinate here. So this is going to be, right, our representation here, right? And x value of 0 would be the year 2003, since 1 represents 2004. So in the year 2003, the life expectancy at birth was 53.18 years in Tanzania. Right? So that would be our interpretation here for the y-intercept. So that'll kind of, let's see if I can fix this here. So that would be our interpretation to the y-intercept, right? So we have that interpretation for the y-intercept. That'll kind of get you started in live. If you have any questions, feel free to email me about those.